Hope I look good. Good morning, everyone. It's really good to finally get to start this class. So, first off, I want to apologize. We haven't started this long, especially to you. We had some expectations. Unfortunately, those two weren't met, but that's all in the past now. So, right, I think we're going to be starting, and it's going to be exciting, right? So, there are lots of things. First off, I want to know how many of us are. Why did you choose networking? You don't know why you chose networking? Why did you choose to learn networking?
That's because I've always loved the idea of being cybersecurity experts and being able to protect the internet from companies
Okay.
and
So,
the
but
cyberspace. But then I found out that I was not eligible enough to go for the cybersecurity. So I had
okay,
to get into the network.
that's correct. You want to do cybersecurity, so yes, you're right. You need networking. That's the most important. So, how about you?
Just like she said, I came here actually wanting to do cybersecurity,
Okay.
but the money was too high.
Okay.
So I saw networking, the money was too high. So so I just
No, I don't think it's actually about the money being high, Sha. I think it's about a prerequisite skill.
yeah,
Networking is the most important skill before that, right? In fact, in your networking, there's a way you do advanced networking. You'd already be doing security. You'll be doing security because, of course, you have to secure a network. If you buy a router or a Wi-Fi and you set a password, you're already employing security. If you say that, okay, you went through your connected devices and you're seeing addresses that you don't know connected to your Wi-Fi, and you copy the addresses and add it to your block list. So those addresses, they can no longer access your network again. That is security. So networking will still give you all of these ideas to the extent where you now want to further, either you want to be an analyst or you want to be the hacker, whichever you want to do, or you just want to know cybersecurity. It will help you scale well because mainly everything you'll be dealing with is networking, right? And that goes to say, if you both that wants to do cybersecurity, what do you think cybersecurity is about? What do you think? Like the instances I've cited, what do you think cybersecurity is mainly about?
protection,
Protecting what?
data,
Protecting data from.
External
hackers,
sources.
Hmm?
External sources.
Okay. I love what you guys are saying. You want to protect data. You want to protect data. I think protection they like using padlock. You want to protect data from external forces, right? Or external actors. Protect. Where are they being stored? Right. They are all stored in a network, right? And of course, we know that there are different kind of networks. Do you remember? You are 300 level in school, abi? How about you?
sorry,
How about you? You're through with tertiary.
yeah, no, it's not.
When?
This year,
What course did you study?
library and information.
Okay, okay. Did you borrow computer science at any point?
We didn't really use the lab.
I want you to learn it for 6 months. You can. Because we'll start talking about network protocols, you start talking about this network, that network, that network, and it will begin to bore you because all of those big grammar, you might not necessarily need it just like that. You really need to get your pretty advanced. At least you have something solid. If you want to play around, let's say SMTP or a file transfer protocol, you just know that you just need a little information. So that was what I was asking, because even in secondary school, I believe secondary schools have taught a little bit on networking, right? And we'll touch some of those things that has been spoken about. And why I was asking is because you that is studying computer science, you must have learned a couple other pretty stuff. If you still remember, when you're talking about, you see, as you're just using your phone, you think everything is just like that. You're learning what helps you transfer files from your phone over a network. There's a protocol that is responsible for that. There's a protocol that is responsible for you to receive those files, right? And all of those things, looking into them in the future. But let's not go and be talking too many stories. So you're actually very, very welcome. There are lots of grammar. There are lots of things that will be scary, right? Especially because when I'm looking at two of you, there's even the most exciting part of networking is where you have to do some coding, or should I say solving. Like, imagine now you have an IP address. They give you an IP address 192.168.2.1 to you have this to 2.7. But 2.7 is much. Let's say you have this to 2.5, right? So this is the IP addresses. Okay, you might not know what IP addresses is. IP address, you know what IP address is now? You know what IP address is? What's IP address?
It's like the address of a particular network.
Is the it's just like, how do I identify you? How do I identify you as a person? No. What unique thing? Like, if I want to tell you, your name, that's your main ID that I can identify you. Then because many other persons might have your name, and this even answers that better. Many other people might have your name. I might not start going into the other details. What's that your name again? Onyeke? Ehinome, yes, Ehinome. So, many other people might have that Ehinome name. Then, maybe if I want to differentiate you. So, the main thing is, everywhere you are, even in church, right, they will advise you go and join a cell or house fellowship, because the entire church might not be able to recognize you, right? But through your cell, it's a smaller unit where you'll be easily recognized. So that's how IP address is. IP address, every object on a network that is receiving and sending communication must have an IP address. Without, it's an IP address that helps you communicate over a network. Without an IP address, you cannot do anything in a network, right? Because where do you come from? Where do you want to send an information from, right? That is why when you hear those information or those news that, like you remember during the last administration or whichever, that what happened that time again? The government banned Twitter. Do you remember? Ban Twitter. We cannot use Twitter now. During Lai Mohammed, yes, now Lai Mohammed, their squad, they say Twitter is. So they will send your ISPs would have a protocol. All they need to do, you see, that goes to, you see what we're still talking about. even the Twitter, as you, all these things you're seeing where you go to that time, twitter.com, why you're able to identify everything on the network is identified by their address. They all have their addresses on the network. They all have their addresses. So because you cannot be cramming address 164.5 or 5, you understand? So there's a way to now use a naming something. It's called DNS. DNS server. It's a server, domain name server. That one masks or assigns names to IP address. So when you go to google.com, that command you are sending, hey, I want to receive this resource from google.com. When you type it, it will go to the server. The server will now feed it the IP address where that google.com is stored, right? So all they need to do is just get that Twitter address, keep it, like put it on like a blacklist, like we're talking about if someone access your network. So that's why anytime you now want to access the Twitter, you can no longer access the Twitter with your SIM card. You know, it's NCC that controls the entire telecoms in Nigeria. And telecoms is what majority of people use. So that's why there are some sites you cannot have access to. But when you use other, internet sources like, say, Starlink now, you realize that you have access to it, right? There are some, even if you're into the blockchain space, there are some of those platforms that don't work with Nigeria system, right? But when you're using a Starlink, you are connected because your internet provider now is not that one that has all those blacklists from all of that, stuff like that. And even with the blacklist now, that's why you still see people use VPNs, right? What's the acronym for VPN? So it's I hope I'm right, Shabo. It's virtual, yes, it's virtual proxy network, right? And you know what proxy is, right? So what it does is that it tries to, whenever you're sending a communication, it hides your own IP address and is feeding another IP address to wherever, so that if they want to track you or what they are seeing is something different, not your own IP address. So you see that you have access to certain resources that you would have been banned from, right? So I wanted to cite an instance. Say we are given you have some slot of available IP addresses. So imagine in this IP address now, there are just, how many? I think there will be like 4 remaining. Because let's say this one is what the router will use. In fact, 2 safe, let's say switch is using it. So you have 3 left. You have 3 IP addresses left. And you want to give it to, let's say, 10 computers. So how do you want to give 10 IP address in just 3 IP address? That's when, when we get to that, we'll start doing what we call subnetting. Subnetting, where as this one, let's say we have 192.168.2.4, right? All of them are using the same, 5 people can be using the same 192.168.4, but in their subnet mask, this one could be using 255.255.253.0. The other one can be using the same thing, 254. The other one, 250. So they are all using, so this thing now gives you the ability to, inside one IP address, 10 devices can share one IP address. when you use the subnet max model. So we'll be doing a lot of little solving where we'll work around that. I think so. That's what I'm saying. That might be like the complicated aspect, but don't be scared. Just do it, right? And to also lay other hold of some of the things we'll be treating, right? You know, when we talk about networking, the biggest company that has really established itself in the entire network thing is Cisco, right? And they even have lots of certification exams, even courses, and it's even their tools we'll be using for this course, right? So one of their tools is that we use is Cisco Packet Tracer. So what that software is all of these things we are saying, you know, when you really want to do networking in practical, you need to get computers, you need to get wire, you need to be crimping the cables, you need to be connecting, pinging physically and testing. And that will be really expensive, right? And time consuming and all of that. So Cisco Packet Tracer is a virtual system or platform where we can do anything we want to do in that software on the platform, right? So and I think that's like a very cool software, and it's very, very important. I think Cisco were really smart to go ensure they do that. You know, take for instance, before any software is built, you have to first of all design it, right? You don't just build the software. You first of all design it, the UX. Before you build a house, you do the architecture work. So you can take whatever you do with the Cisco platform as more like all the work, because once you do it on the system, you can literally, it's virtual, but you can see everything. You can see your computer, you can see the hardware ports, how it will look like. You see everything there, so that when you even go and see it in real life, it doesn't look new or surprising to you. You've already interacted with something like that before. So you can use it, you can network an entire city from that software. And everything you do, all you just have to do is take it like that and go and do it in real. You know, the thing is, you know that, okay, whatever you're doing, you have to continue working with the Cisco devices, because everything you're using there are Cisco devices, Cisco switches, Cisco routers. So, and I think Cisco the devices might be a little bit expensive compared to others, but yes, they are like the industry standard. So they have a course called CCNA. So by the time we train you, which is their associate level, they have different levels, of course. They have CCNA, they have CCNP, the likes like that. So which is what we're training you for. So by the time we train you, you can now even go, if you have the money and if you are in love with networking, you can go and take the course. I say take the course, take the examination. We'll prepare you to pass for the examination. Take the examination. I think their certificate lasts for about 3 years. So if you have a job that needs the certification, we go and take it. We'll teach you everything. So everything we'll be using will be the CCNA standard. CCNA is the standard for networking class. So we'll be working with the CCNA curricula and standard, right? So yes, that has to be known. So if you have like $300, you can go and pay for
You can apply for the Cisco exam and get a certificate that will last for 3 years, right? Yeah, so that's that. So I'm just saying all of this more like
lay the background, so we really know what we want to do, right? So I think we should just get right into it. So with all this being said, I think we need to buy more markers. Maybe we'll buy that pack. So For today, we're just going to be doing a little intro to networking. We'll be having a conversation of what exactly is networking, what is it all about, and I really want to hear from you. Let's go. What is networking? What's your understanding of networking? Or what is a network?
Interacting with other networks to gain information.
Okay, so I think of what I asked you. I said, what is a network? Okay, maybe, okay, no problem. You're still correct. You're still correct. It's fine. Well done. You have any additions to that? You have any addition to add? This is normal secondary school stuff. Clap for him now. Right? So, networking or network is that system, right, that enables devices share resources, right? That system that enables devices share resources. So, like, you think as you just use your phone and download a movie, you're doing that over a network, right? The file protocol helped that file be stored through a network over a server, right? Now your device being the client device wants to access it and it gives it to you over a network, right? So that is very, very correct. So I don't have any like notes prepared. I don't know how to prepare notes like that. So but I went through some materials which I'm going to display for us. So that network university, da 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 da. So we'll just be working with this for now. Let's look at our definition of network. What's a network? I would say this together. 2, 1, go.
So for more computers that have been connected in order to enable them to communicate with each other and share resources and files.
So, there are devices. So, only computers. Devices. The ability for devices to share resources or communicate is really possible by a network. And now, we're going into components of the network, right? What makes up the network? We're not talking about the network, what makes up that network? And there are many, but we're looking at the 5 core components of that, of the network. I will see there are clients, servers, channels, interface devices, and operating systems. Right? Clients, servers, and clients. If you want to break it down, mainly a lot of time you see that the two core major parts of the network are the clients and the servers. And what are clients? Anytime you're requesting something, anytime you're requesting a service or a resource, anytime you're on the receiving end of a client, and the server is the opposite. The server is the one that gives. It's something like beggar and taker. Right? But don't get confused. Even a client can also be a server. Right?
resources are being exchanged. Okay, let's take something very basic, for instance, power. Let's say drive or whichever is. You want to save your files there, right? So at the moment where it's asking you to upload the files, it is your phone that is the server, right? Because that's where the pictures, that's where the resource are stored, the videos, where you're taking it to your device and once saving it. And once it has received it, so tomorrow, if you want to take back the files, you go there and you download it. It has now become the server. Your device or that phone at that point is now the client, right? Now we can see this definition here. It says servers. So that is called host computers. Host computers.
Servers are powerful computers that store data or applications
And connect to resources that are shared by the users of the network.
Servers are powerful computers that stores data or applications.
And connect to resources that are shared by the users.
The definition I gave to you guys initially, that's like the basic of server. Whatever this person is trying to tell here, we have, when you go deep into networking, even though you don't go deep, of course, you know that there are computers
That are just servers, right? Their primary role, they have all the resources. Like when you go to Google Data Center now, you will see like 50,000 rows of different computers connected together. All of those computers are servers, right? They are all they are holding all the information, they are all the resources, and it is feeding people all over the world daily, millions of times, sending requests that people are making. Hey, I need this resource. Gives you your search result. Hey, this. So that's that, right? Now, clients, what are clients? Clients are computers used by the server of the network to access the servers and share resources. Right? Like clients are those ones that request the service.
computers. So everything can be a client actually. Your phone. Is it these days? It is typical for a client to be a personal computer that the users also use for their own non-network applications. For example, the computers in the okay, maybe that will be from their school because we don't know that. So next thing there is channels. Can we define channels from
1, 2, 3, go.
okay? So I don't know, but channels are the pathway through which channels are the pathway through which information travels between the different computers, right? What's that pathway? Like the instances we've been speaking about here, exchanging data with your Google Drive or whichever. What pathway are we using to achieve that? What pathway are we using to achieve that? When you want to upload something to your cloud storage or you want to retrieve a file from your cloud storage, what pathway do we use to achieve that?
Use the app.
Hey, Jesus, is that the pathway? What did you say channels are?
Clients and servers.
The channel is the pathway over which information travels. Okay, the information travels through your app. So that is the internet now. What's up? We're talking about, you don't know internet is a network? Internet is a network now. Like Come on, primary school stuff. Types of network. We have LAN, right? MAN and WAN, right? So local area network. If we decide to do our own local network here, so we'll have LAN cables and so even though we don't even do LAN cable, like we have a router here. That router that is to serve us here, that is a LAN, right? So we can still decide to connect some. Our router has the ability to serve wirelessly, and of course through LAN, we can still decide to pass LAN cables, connect to a switch, and serve computers. So that is LAN, local, something that is within a space. Then MAN, which is like the metropolitan area network or whichever, is the one that you use. You use like maybe school. The one a school can use, because of course if you can cover a school with an internet, right? Some schools are as big as some cities. Some schools are bigger than some cities, especially in Nigeria here. Yeah, you go to schools like Uniport, Futo, just have crazy kind of land that's wasting, right? Then when we're talking about wide area network now, this is one that can span regions. You can even expand it to nations. You can expand it so you can group internet there, or you can group internet beyond that, whichever. So that is the channel through which all of these things goes through. I hope we are taking note of that. And from the picture that was seen on that screen, tell me like the three key things you see or notice. You see the computers, right? What other thing do you see? Servers. What other thing do you see? Clients. That is the computer now. Server, clients. What other thing do you see? What's happening? Let's try. Not unplug on the user. Unplug me. Okay. So I think I'll just bring my laptop here so I don't have to be going back and forth. So the channel in this connection here now, what do you think? Okay. What do you think the channel would be? What do you think the channel would be? What is the channel in this setup here now? As I've told you, the channel for the instance I cited initially is internet. What do you think the channel here is? It's LAN now. Oh my God. It's like, we're going to teach you people computer appreciation first. Oh. Are you not seeing that wire that is going everywhere? How will you say wire? That is LAN now. Those are cables. Those are cables, right? This is like a LAN system. So whichever. So these are like Ethernet cables. You can see server, some computers, and printer. So you can be in an office where you want to print, and those are even the kind of printer I want to buy. As far as all of us are connected in the same network, you don't have to go and be connecting. You can send to print from over the network, and the printer would receive that. And then the next thing we have here is interface devices. And interface devices says they are the devices that connect clients and servers. Right? So they connect clients and servers and other networks to the channel. Those are internet devices. And he said one of that interface device is modems. Of course, you know what modem is. So maybe somebody that doesn't have, let's say we set up a LAN. Someone that doesn't have access to our LAN wants to connect. So those devices that can enable them share our resource. Right? And then the final thing we have here is operating systems. So you see that everything that makes anything work is being powered by an operating system. For you to be able to interact with your phone is, of course, whether you're using an iOS or an Android, right? And most times, you know, the network system you could and network, right? For standalone computers. So all of these other three things are like little extras, like I was speaking about earlier. That's why I said, like, the most important things, right, are mainly that client and servers, and maybe the interface. So when we're talking about, I think here, the main focus now is trying to help us see, and I think it's pretty cool because we seemed to not really understand network channels very well. So we say network channels come in a variety of types.
sending and receiving files at the same time. Or in other words, you can still use the word downloading and uploading. Right? So those are full nets. Before looking at the transmission network channels. Four important dimensions of channels. Music, transmission rates or bandwidth. So another mode is the signal type. There are two signal types, another that it's a little hard to understand the exact difference without discussing a lot of electrical and engineering and physics. So we will go there, right? What's going to take away is that analog signals are continuous. They make on a wide range of values, and digital signals are discrete and binary. Take on only two values. What are the two values? Zeros and ones, very correct. Digital signals are more natural. For computers, since as we know, computers represent all the information in binary. Those this thing will be like analog. They want to do analog computer. Numbers go long. Even in binaries, a lot of stress alone, right? Because I remember when I was in like 200 level back then, when if you do an offense, our teacher will write an apology letter in binary. So imagine you just want to write sorry. You can fool how many pages like this for just one sorry word. Because hexadecimal now, I think it stops at F. Like, is it F9 or F10? Down to bring down that highest F to its binary division. When you bring it down, you see you might have 1 1. Then you have to do that for S, for O, for R, for Y. So it was very exciting. And you just be looking at one small letter that you wrote, and you have how many pages? And computer is doing this in split seconds. We are sending messages, how are you doing? We think computer is understanding how are you doing. Or you're uploading a video. You're uploading a picture or a video to a drive. You don't know that it will first of all break that thing, split it into bytes. Once it moves it, that's what helps it move it faster. Once it moves it, then it now reassembles it back into what you know, see or understand. So it's very exciting. Now, this is another exciting part that we'll be looking at, right? The LAN, the MAN, and the WAN, which we've spoken about, right? LAN, MAN, and WAN, right? And like we said, what's that showing there? The reason why we have to worry about analog signal is because because the communications channels that predated computer networks like telephone lines, cable TV, and radio transmitter were all designed to carry analog signals. Oh wow. Telephone lines, cable TV, wow. Okay. So, third, what are we looking at again? No, like, what are we looking at? Is it network channels? Is it types of network channels or what?
Network channel what now?
Dimensions.
Okay, understanding network channels.
Dimensions of channels.
Okay, dimensions of network channels. Okay, that one too is fine. So this one now, this dimension is mainly about the geographic scope, right? We're talking about the geographic scope. Now, what does that help us do or no, right? It says the simplest, so that is the space it occupies or whatever. And number one thing we're looking at here already is LAN. And like we said, LAN is an acronym for local area network, which is like that local area, right? A LAN is confined to a fairly small geographic area. So if we decide to like even network this entire building that we are on, is a LAN. Is a LAN. Is a fairly small geographic area. The clients and servers on a LAN are connected to the same channel and are typically in the same building or in neighboring buildings. So if that, even though that building is, say, 4-story building, right, or 6-story buildings, and you network that building, it's a LAN, right? And what is backbone network again now? These are high bandwidth channels that typically connect LANs with each other and are often referred to as backbones. Okay. So metropolitan area networks and wide area networks. Like we said, a man spans a wider geographic area like a corporate campus or a university, while one is spread over a large geographic area such as a country or a state. And I think we've spoken about this, right? So now, this is another very interesting part in networking. We're going to be looking at networking protocols. Networking protocols. And there are lots of protocols, and we really have to pay very serious attention to this, right? So it says most networks have one feature in common, right? And I think I've still said this. How do network? Okay, can we read this first line? 2, 1, go.
Most networks have one feature in common. We transmit information by breaking the original information into a set of messages called packets.
That's how all of that works. It breaks it down into packets. That is like small chunks of information. Then once it arrives wherever it's going, it builds up back to its initial state.
So that's like subnetting.
Huh?
Is that like subnetting?
No. Subnetting is when many devices want to share one IP address. That's like a different thing. It's just what it's more like. It's like when you were taught in school, bits, 8 bits makes 1 byte, right? Then 10,024 bytes make 1 kilobyte. 1024 bytes make 1 kilobyte. 1024 kilobytes make 1 megabyte. The same thing, gigabyte. It's only in bits that it is 8. 8 bits is what makes 1 byte, right? So this is what we're saying in case. This is what we say, bits. 8 bits is this one. Makes 1 byte. Then 1024 bytes make 1 kilobyte. 1024 kilobytes make 1 megabyte, and it keeps going. So non-network persons, Even the same thing happens when you buy your internet data from your telecom. When you buy, let's say you buy 10 gig, or let's use something that we understand. Let's say you buy 1 gig, you should be getting 10,000 and 10,000 is 1,000 MB. You say, they dashed me 24 MB. You just say that, okay, these guys are not really, they're not really in the computer this thing. Even if a network gives you 1,000 gigabytes and tell you it's terabytes, that network will short your data. Because imagine 24 times 1,000. That's a lot of data they've eaten from you already. But because majority of people don't know, so they'll just play on that. So, right, can we continue reading? Set of messages called packets. Okay, go ahead.
Transmitting these packets sequentially, and then we are sending these packets back
Into the original information. So it will first of all break it down into those small chunks. And I think it's exciting that I've already said this before. It's just nice to get to see it. So that's how communication really takes place. Whenever you see something transferring very fast, you just know that maybe that system has the ability to break that information you want to send into many chunks and has a very high speed of transmitting those chunks and reassembling them, right? So that is how that works. So each packet is and this is also what we've also said. Each packet is a string of bits, right? However, these packets sometimes have to travel a long way over a bunch of different networks. There are typically lots of computers sending and receiving information over the same network, and information getting sent can often get altered during transmission. This is called a transmission error. Have you ever noticed that you are sending a file, or in fact, when you are downloading, after a while, when you think it is almost done, it will not tell you failed. I don't think you people know the pain we experience that time where we'll be downloading song or game. We'll hold our phone like this. We'll be running. You guys never experienced that era? Yes. I don't know. It was an exciting generation. No? The time if I'm downloading like this, I'll just put my phone on here and I'll be running. And the funny thing is the illusion that this thing actually works. I don't know if it actually works. Because if you are standing in one place, the downloading will be very small. But once you start running and be going, you'll be seeing him move fast. Before you know it, I would have covered like 2-3 kilometers. I'll say, yes, it's almost there. Then it will not get to 98%. I will not see failed. One thing I noticed that period is that, and that time is 10 MB that is the highest MB we used to do. Nobody used to do more than 10 MB. So once I have down my full 10 MB like this, it's funny, right? Once I have my full 10 MB like this, anything I want to download, will download once. But once that my MB go below 5 MB, it will keep failing. That was what I noticed. Even though I have enough data, I don't know why those network people are doing those things on purpose. So if I want to download large files, I must make sure I have when I say large files, I mean songs, like 3 MB, 4 MB. Normally, the best game like Symbian phone, best game was like 2 MB. They good quality games. Assassin's Creed with many missions. Tell you very high brothers in arms. 2 MB, 1 MB. I don't know when we started downloading games in
500 MB.
this time is 500 MB. That means that game is not sweet. If that game is not taking If that game is not taken from like 2 gig, you know that that game will not be interesting. So like, and I used to wonder, but do you know why games then had very low size and very plenty stories? Yeah? I think it was also like the technology they were built with also has a great contributor too. Like many of those things were built with C. I've written a program with JavaScript before. And I think that file was a big file. The file took me about, that JavaScript file was about 100 kilobytes. And I tried to do that same thing with C. The only difference I see will make you write many, many lines of code. I did that same thing with C. And I think the entire file was just around 5 kilobytes or 10 kilobytes. So you can imagine how, I don't know how C does it, but your file size, and imagine then that was what was used to build games. So the more a technology is depending on another technology, that stack keeps getting high, which also one way or the other affects the size too. I think so, because yeah, that's just the best explanation. Maybe this one will be depending on this one for higher definition video display. Then what do you want to use 2K, 4K display to do? You don't need it now. It was normal. It was not even up to 720p because it was button phones. So right, so all of those things, that's that transmission error that you see. So it's, and why that transmission error occurs or happens is because you're not the only person that is using that network, right? So because a lot of persons are trying to access information over that network, it's going to be a bit slow. It will be slow because others are doing their thing. So if it doesn't complete its stuff, it will just fail. And the correct term is transmission error. But you will not understand transmission error. So that's why even when you're writing code, you advise to use stand. You're seeing terms like download failed, upload failed. They will not tell you transmission error. You will not understand. So in order to make sure that the original information gets transmitted correctly, efficiently, and to the right place, computer networks uses a set of rules called networking protocols, right? And like we were saying initially, these protocols are what is responsible for everything we do over in the network, over a network. Networking protocols could constitute, like I said, I think, why is this guy saying everything I said? I should have just gone through this thing now. It can take us, like I said initially, it can take you months to learn about these networking protocols, but it's not something we need that much. So we'll look at the primary tasks that we use our protocols for. And they fall in 2 main categories: network layer tasks and data link layer tasks. Network layer and data link. Network layer and data link, right? So whenever we're working with that, of course, you know that what is being dealt on in that aspect is usually, you just add the protocol, network layer protocol, data link layer protocol, whichever. So the first one, network layer protocols. The following 3 tasks. Number one, packetizing, which is breaking up information into packets and assembling the packets at the receiving end. To break up the information into packets and assemble the packet at the receiving end. So you can take this instance for example now. This is like the packets. This is how information is being stored when we're talking about packets. This is the bits. 0, 1, 0, 1, 0, 0, 0, stuff like that. You say, let's say you want to go to Amazon.com, right? That your Amazon.com command you sent over the web, it breaks it down into packets. Because of course you cannot send Amazon.com over the network. So your Google Chrome is already doing all of the underground work that you don't know, right? So it breaks it down, it now sends the packet. That's why you see that loading speed, because it will break it down and that's the packetizing. Get that packet over the network, which in this case we can call it the internet. Now, the packet received by a receiver's computer, the receiver on this end would be like, let's say, the Amazon server. It will now receive these packets that you sent. Then it will reassemble the packets. To reassemble it, and what you will see is this. You will now see what you are looking for. Whichever you want to do, even though if you want to use this Amazon.com as a picture, as you are sending a picture, it is breaking that picture down. This is literally what that computer is working with in the background that you don't know. It will break it down, send it through the network, and then whoever you are sending it to will receive it. Then the computer will reassemble it back to what you have sent that you understand, for that receiver to see and understand. And you know, man, this your face is as if, what have I gotten myself into? It's exciting, right? You know, some of these things are really nice, you know. Sometimes all these things will help you, how do I say this, like, appreciate life. Because there are certain things that, you're just living your life, you're just doing your things. You think that's how things works. Until you get to understand or get yourself involved into how people are always doing TikTok, shaking bomb on TikTok. Let those people come and learn what enables all of those things. They'll be like, somebody built this thing, Jesus, right? When you go to, let's say you're in this hub now, you're looking at it, this hub is not really that fine. I wish this thing is here, this thing is here. Until you now want to set up one small shop for yourself. You say, that hub that I said doesn't have this and that. That hub try, Jesus. Or you just be seeing people building and say, hey, this person have money. But you will not understand the kind of money you have until you want to build one small bungalow. You now start calculating, how did this person build this 8-story building? So it helps you appreciate life. You get to see things differently, right? You get to see the nitty-gritty. Even though when you do a course, let's say you want to do web development now, by the time you do web development, websites, you start seeing websites differently. You'll be seeing the beauty, you'll be seeing the struggle. You get into some websites, you'll be wondering, how did this guy do this thing? You know, people that don't know, their own is to just go and use it. But when you learn it, you start seeing the concept. It's like, how did this guy do this thing? You are looking at a different thing from somebody else. It's like, this guy bad, though. When people are seeing animation on your website, they think it's a small work, right? So then the other option we've looked at packetizing. Next thing here is the addressing. And addressing is simply determining the computer that the packets are heading to. The packet that is being sent, where is it going to? Then routing, determining the best way. What's the best way for the packet to arrive where it wants to go to? And now TCP/IP protocol, another very, very big protocol that really powers like the network layer. I think there are two models. We have the TCP/IP and we have the OSI, but I think we can just focus on the TCP/IP for now. The TCP/IP is a network layer protocol and currently the most common one, right? And TCP/IP protocol stands for Transmission Control Protocol Internet Protocol, right? IP, Internet Protocol. And now our Transmission Control Protocol / Internet Protocol, right? Then we have the data link layer protocols, which is called layer 2 protocols. And I think maybe in the next class, we would calm down and I'll really explain what is it, why are we talking layer 1, layer 2, layer 3. I think maybe we use a diagram to explain that. When you're seeing your computer, you have the hardware. Don't worry, let me not get into that. Right? So data link layer protocols, also called layer 3. Remember, network protocols is what? Is layer 3. So data link layer is layer 2. And it specifies how network does three main tasks. Delineation, which is figuring out when a message begins and ends. When a packet begins and ends. Error control, figuring out when a transmission error has occurred and correcting it. Channel access, controlling when a particular client or server accesses the channel. So these data link layer protocols, one of the most popular pattern of which it uses to is the Ethernet, right? There are a wide variety of data link layer protocols. The most common in organizations and universities is Ethernet, which was first network protocol. So, well, that's the data link protocol it's talking about. But do we know about Ethernet? Ethernet, yeah. Ethernet, or I don't know. Yes, those cables which you use for, even you can still use it for your LAN. It's been years ago that came about. So maybe one of these days we can touch on that. What does this picture represent? Okay, picture of first Ethernet schematic drawn by its inventor. Well, this guy is good though. So now, I think the final dimension we'll look at, which is also something we should have learnt in our school, which is something you can also go and look and try to learn more about, is network topologies. Do you remember when they were teaching you network topology? So you will learn it, but we will not practice that one. Maybe you go and look for where you practice that one. So topology, of course, is like the arrangement you choose to do your network setup. So I think we can also like, can we read what we have on the board, on the screen?
The topology of
The basic geometric layout of how clients and servers are connected. The three common network topologies are star, ring, and bus. So there are many more. So, but this is like the basic ones that people fuck with the most. So this is the bus topology. That's how it looks like the setup. That straight line, putting a cable like this and outlets to each device. Then this is how ring looks like. Setting up everything at the center and having everybody connect and share resources. And this is how the star is. Alright? So modems and Ethernet cards. In every LAN, one needs network interface devices to connect to clients. Okay. So you really cannot talk about LANs. I think you can. Most times when we're talking about running LANs or setting up LANs, it's always with the use of Ethernet cables, and we brought some cables that we'll use to set all of that up. I think we can really end today's class here. If you want this file, I'll share with you. What's the time? 11:47. Okay, we have time, Abby. What are we supposed to cover today in that curricula in day one? So I want us to sorry. Thank you. Okay. Today, I think we'll do that then. I was hoping to do notes. I said no, I don't have that strength. So, but you see some of these pictures you're seeing here, this is how, when we start interacting with the Cisco packet tracer, this is how we'll be walking around. You have cable, you have the connectors, you have the computers, and all of that. So you can see the TCP IP protocol, right? These are mainly, it has like 4 main layers: application layer, transport layer, internet layer, and network access layer, right? Network access layer is like the lowest. Network access is like, okay, how are you able to access the network, right? Next layer is the internet layer. That's where the IP addressing comes in. How is able to assign you IP address, get you connected to the internet and stuff. Transport layer is where when you want to transfer files or receive files, that is where is responsible for handling all of that. Then the topmost layer is the application layer, and you can see some things that runs on the application layer, right? On the protocol, DNS server. Like we said, what is DNS? It's the one that assigns name. So if on the network I don't want to be typing your IP address, let's say you are 192.168.0.1, you are 1.1, you are 1.2, I don't want to be using that IP address to access you guys. I want to use your name. I'll just type ehis like you like. So that anytime I type ehis, it will go to the DNS. DNS, who is ehis? DNS will now feed it the IP address to now go straight to the IP address. DHCP, Dynamic Host Configuration Protocol. That one is, what it does is it automatically assigns IP address. You can assign IP address manually. You can let it assign automatically. So that's what that one does. IMAP, SMTP, those ones are in email protocol. This is file transfer protocol, like we are saying. How you're able to transfer files, there's a protocol that helps you do that. And of course the web, another protocol, Hypertext Transport Protocol, helps you actually access the web. Let me see if this bad guy is loaded yet. Framework with 7 layers that shows how data communication should work. While the TCP/IP model is a practical model with 4 layers. Are you seeing it? TCP/IP is literally where everything, what is being used. Like this OSI model just came out newly. I'm trying to show you 7 layers and stuff. TCP/IP model is a practical model with 4 layers that is actually used in real-world networking. OSI model, this is what it stands for: Open Systems Interconnection Layer. It has 7 layers, and these are the 7 layers it has: physical layer, data link layer, network layer, transport layer, session layer, presentation layer, and application layer. And you know the funny thing? Everything that we do, use, or interact with now, they all developed like in the 80s, from the 1800s to like, I will not be wondering sometimes, is it that this generation is not really creative? Like, see when OSI model was developed, 1984. Now imagine when the TCP was developed, because TCP was way older than it. Even the aeroplane we are flying today, it's not today it came out. This AI that we're talking about, it's not today it came out, it was in the 90s. I think this generation is a bit backward. Yeah, because by now we are supposed to be flying. Everybody's just, are you not seeing his size? Everybody's just living soft life. Nobody cares about things again. Everything we are enjoying in this generation, they were all built like 2 generations ago. The idea of fast cars, the idea of football. Like, I just be thinking there's nothing present that exists like that we say we formed. The football that everybody like play, it started how many decades ago? Formula One, all of them. And those people that were doing it then, if you fuck up, you have died. They were dealing with that much risk. But now there's just so much safety. Even though your car explodes, you will come out with all those their special suits. And these special suits were still designed since. So we really have to we need to be very, very innovative. Internet, it was not now it came out. In fact, the guy that invented the internet, he made it free. What we know how to do is to monetize it. So these are the 7 layers. Application layer is responsible for providing services to the user. Presentation layer, and we've mentioned some of those application layers when I was talking about TCP/IP. Presentation layer take care of syntax and semantics of the information exchange. Session layer establish, maintain, synchronize, and terminate the interaction between sender and receiver. Responsible for process of responsible for delivery of individual packets from source to destination. Okay, that's interesting. And then physical layer. Data flow in OSI model. I think this is really an exciting thing we should always look out for. How does data flow? It really helps us understand better. Okay, what year was it done? 1970s. Okay, that's interesting. And you know that something even came out in 1970 does not really mean they started thinking about it in 1970. Some things will take years to be finally invented, right? So, this is one thing I was looking out for. This is like, you can see from this now, these 2 protocols here. In the TCP/IP model, everything is called the application layer, right? This is all the protocols that are responsible in that application layer, like we've spoken about initially: DNS, HTTP, SMTP, Telnet, all of that. A group, all of them are inside one application layer. But what did OSI model do? OSI model broke down application layer into 3 different layers. Presentation and session. It added presentation and session, right? That was one of the things he used to add more. Then transport layer and network layer, internet layer remains the same. Then we have network access layer, of course, to access the network. We broke it down into physical and data link layer. I think that's like the major difference there, splitting it into the, and this is really an important diagram. So for the assignment today, you can even start your assignment now since we've closed earlier. You're going to I need you to study on analog and digital. What was that thing again? Analog and digital, what was that again? I need you to study analog and digital signal types, and we are going to discuss it in the next class. And I need you to also study these network models, network protocol models, especially the TCP/IP and OSI models. You tell us what you learned. I want to see the diagram differentiating them. So yes, I think these 2 things will be nice. We get to work on. Yeah, collect it from her. So thank you so much for the class. Is there any question?